Hello. Today we'll be looking at loops, and for your loops, there are three main loops that you have in your C language, which is equally common with other language. You have the for loop, the while loop, and the do while loop. The structure or the syntax for your for loop is that you have uh, the initialization or the initializing statement or expression. Then you have a condition. Then your condition, if the condition is true, you have a statement to be executed, and after that statement is executed, there will be an increment or a decrement, which will go back into the condition. If it's still true, the statement is executed, increment or decrement, condition, until this condition is false before the for loop is terminated. So this is the structure. Let me show you the structure of your for loop here. This is the for loop. So you have the for, you have in bracket here, you have three components. Number one is your initialization, you have your semicolon, then the condition, then you have increment or decrement. So as long as this condition is true, this statement will be executed until this condition is false before this for loop can be terminated. So this is just an example in C language. So you have, this is the initialization in this case, I equal to 1. So here we are initializing the value of I as 1, and the condition here is that is I less than 11. So long I is less than 11, there will be an increment of 1. That is the plus plus I that you have, and this is the increment. If it's minus minus I, it will be a decrement. So in this case, you have initialization, you have the condition, and you have the increment. So, but our I here is an identifier, and we need to specify the data type. So I here is an identifier, and the data type is an integer in this case, because we are actually checking if I is less than 11. So long this condition is true, this statement here would be executed. So long that condition is true, let me just add a new line sequence here. So when you run this, what will happen is 1 to 10 will be printed. You can see 1, 2, 3 up until 10 is printed, because the condition here is that I must be less than 11 for this statement to be executed, and the next time after 10 I will be equal to 11. So definitely this condition will turn out to be false at that time. So that is why 11 is not included here. But if I put in less than or equal to 11, then 11 will be included in. You can see here now that 11 is included, because the condition is I must be less than or equal to 11. So it's until I is greater than 11 now that this condition turns out to be false, and that is why 12 is not printed here. So we can do the same for decrements. So we can also do the same for decrements, and if you are doing that, then we're initializing I with a high value, and here it would be, okay, let's take this one as 0, and in this case it will be I greater than, and here will be negative negative, because it's decrement in this case. So what will happen now is the value of I is being initialized as 11. That's initialization for the for loop, and the condition is I greater than 0. So as long as I is greater than 0, then the value of I will be decreased by 1 until this condition is false. So if you run this one now, it will be printed from 11 to 1, because the next count now, the value of I will be 0, and this condition will be false. So that is why 0 is not printed here. So if I want 0 to be printed, it will be greater than or equal to 0 in this case. So if you run that again, you can see 0 is being printed now. So that is for your for loop. There are 3 components of your for loop: initialization, separated by semicolon, the condition, and the increment or decrement. In this case, it's decrement. So let's also look at another example of your for loop. So here now, I want to check the sum of numbers. I want to sum some numbers. So here you have the number as an identifier, count as another identifier, and sum as another identifier, which the value here is being initialized with 0. So, and all are of data type integer. So that's why you have int, and all the identifiers are stated as it is. So what will first happen is that this program will request the user to put in a positive integer, and that will be taken in with the scan function as number, which is num, will be taken in as num. So whatever the user put in will be taken as variable, or the identifier none. So this is the for loop line, and here you have the count as the initializing variable in this case, which is being initialized as 1, and you have count less than or equal to num, which means so long count is less than or equal to num, the value of count will be increased by 1. So this is increment, this is the condition, and this is the initialization. That's your for loop. So these are the statements in the for loop. So once this condition is true, once count is less than or equal to num, then these 2 statements will be executed. And what will be happening here is that the value of count will be adding up. That's what you have at sum plus equal count. What you have here is that this plus equals means that this value will be added to itself. So, and this will be printed here, and what will be printed here is just the count will be printed. Maybe 1, 2, 3, 4, 5 will be printed here. So as much as this expression is true, this condition is true, these 2 statements will be executed until this turn out to be false. Now the total sum will now be printed, which is this line. So if this condition turn out to be false, that means at that time your count is now greater than none. Then this expression here will be printed. So if you run this, so to ask the user to put in a positive integer. So if you put in 2, so 2 now will be the none, and your starting count as 1. So it's only 1 and 2 that will be listed, and the sum would be 3 in this case. So you can see, so I'm starting count as 1 and I'm putting none as 2. So count less than or equal to 2. The value of count will increase by 1. So initial value of count is 1, and adding 1 to the value of count, which is 1 plus 1, will be equal to 2. And at that point, when count equals to 2, this condition has been satisfied. So the next time count will be greater than none, so that condition will be false. So this for loop will be terminated, and 1 and 2 is added. That is this plus equals count. So you are adding the value of count. 1 plus 2 equals to 3, and the total sum is printed, which is 3. So sum equal 3. We can do that also for another number. Let's run this again. If I put in 10 in this case, I put in 10 here, so that will be 1 to 10. You can see 1 to 10, and if you had 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, you have 55 as your total sum. So that is what this for loop is doing. So it's just adding numbers in succession as long as it is less than this norm, as long as this condition is true. So the next loop we'll be looking at is your your while loop. So for a while loop, you have a particular decision for a while loop. Once that decision is true, then you want a statement to be executed. At the time that decision is false, then that loop will be terminated. So what you're saying is that while this condition is true, this statement will be executed, and while this condition is false, then another statement will be done. So this is the while loop syntax. You have a test expression for your while. So while this test expression is true, then this line of code will be executed until this test expression is false before this while loop will be terminated. So let's look at that here. Let's open the while loop. So this is the while loop. So you have the expression as I less than or equal to 5. That is the test expression for the while loop. So as long as I is less than or equal to 5, this statement would be executed. So because I here is a data type, is an identifier, the data type has to be specified. So the data type here is specified as an integer in this case. So, and the value of I is initialized as 1. So, and 1 is less than or equal to 5. So long this expression here is true, then this statement will be executed. But also you have to note that because you are using a while loop, there has to be an increment or decrement, because without an increment or decrement, there's no way the while loop will be terminated. If you don't put in an increment in this case, is if I is not being increased until this condition is false, this loop will never be terminated. So that is why the increment statement has to be put here within the while loop, within this while loop, which means after this line has been executed, the next line that will be executed is this. This statement will be executed first, next this statement. So 1 will be printed and 1 will be added to 1. So the next time I will be 2, the next time I will be 3, the next time I will be 4, the next time I will be 5, so that this loop can be terminated. Else this loop will never be terminated. So if you run this, you can see this is 1, 2, 3, 4, 5. After 5, this condition turned out to be false. So this loop would be terminated. So that is for your while loop. So this is your expression, and you want this statement to be executed while this expression is true. But for this expression to turn out to be false, so that the while loop can be terminated, your test expression needs an increment or a decrement depending on what you have put in here, depending on the condition, so that your variable or your identifier here would turn out to make this condition false. If you want to do this for decrement now, you just need to put greater than or equal to 0, and this one will be 5 in this case, or let me put in 10 in this case, and here will be negative because this is decrement. So we are initializing the value of I as 10, and the expression here is checking if I is greater than or equal to 0. So long this expression is true, this statement will be executed. And once this line is executed, which means the value of I will be printed, the next thing that will be done is that there will be a decrease in the value of I by 1. So until when this expression is false, before this loop is terminated. So you can see it is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. You can see, so that is the decrement example for your while loop. And the next one we want to look at is your do while loop. So if you look at a do while loop, for a do while loop, you want the system or the program to keep doing something while a test expression is true. So you want the system to keep doing something while a test expression is true. So in this case now, you have a statement. You want the statement to continue to be executed while this condition is true. So long this condition is true, this statement will be executed repeatedly until the condition turns out to be false before the loop is executed. So that is how your do while loop operates. So let's look at your do while loop in this case. So for your do while loop, let's open that. So you have your do while loop. So here what's happening here is we have two identifier, which is your number and your sum, which are both double, and the sum is being initialized to 0. Now you have your do loop. Now in this do loop you have your statement. This is the body of your do loop in between these two curly brackets. You can see that it's being highlighted. So these are your do statements. So you want the user to enter a number, and that number will be taken in as the identifier number. Because the identifier number is a double data type, that is why you are having LF as the character type for your scan function. And we are using this plus equal also to be adding the value of the number together. So all of this will be done repeatedly until what you have in this while loop, this while expression, is false. And the condition in this while expression is that so long the number that is being entered by the user is not equal to 0. That's why you have this apostrophe. Sorry, that's why you have this exclamation mark and equal to. These two together is your not equal to. So long the number that is entered by the user is not equal to 0, this do loop statements will be executed repeatedly until this condition turns out to be false. So that is what you have in a do while loop. So and at the time this condition turns out to be false, then this line will be executed, which is the while statement. In this case, that will be the total sum of the number that has been imputed by the user. So if you run this now, the first thing that will happen is that the user is being requested to enter a number, which is this line, the first line of your do loop. This is your do statement. So if the user enters 7, because 7 is not less than 0 and is not equal to 0, then this while expression is true. If you push in enter, you can see that what happens here is that it tells the user again to put in another number. If you put in 9, it will tell the user to put in another number, because every number that is being entered, 7, 9, and 3, they are not less than 0. Because the while expression is that so far the number that is being entered is not equal to 0. Then what you have in the do loop will keep on being executed. And 7, 9, and 3 are not 0. So if you push in enter again, you can see, pushing enter again, you can see, pushing enter again, until I put in 0 now. You can see, because at the time I put in 0, this while expression turned out to be false, because at that time the number entered by the user, which is 0 in this case, is equal to 0. Then this expression turned out to be false. Then the while statement is executed, which is the sum of what has been entered by the user. All of this, it is being printed here. So that is your do while loop. Now, there are some cases when you're having to run a loop that you want the loop to be terminated at some instance, or you want a particular instance in the loop to be skipped. So at the time you want a particular instance in a loop to be terminated, if an instance should occur in a loop, you want that loop to be terminated, then you'll be using the break statement. But if at an instance in a loop you want that instance to be skipped, then in that instance you'll be using the continue statement. So the next thing we're looking at is your continue and the break statement. So for the continue statement, here you have your for loop, because for you to use continue or break, it has to be in a loop. So is that you're using it in a for loop, in a while loop, or a do while loop. So in this case, we are using the continue in a for loop. So like we already said, we have 3 identifier: number, sum, then I. I is of the data type integer, number and sum are of the data type double, and sum is being initialized as 0. So this is the for loop, and initializing the for loop with I equal to 1. The condition here is that I is less than or equal to 0 or equal to 10, and here you have the increment in this case. So this is the for statement. So long this condition is true, these two statements will be executed, which is for the user to end, the number entered by the user will be taken as the value of I, and the scan function will take in that number. Now you want to check, in this case, if the number entered by the user is less than 0, you want that number to be skipped. That is why you have the continue. So what the continue will do is, if this expression here in this if statement is true, that instance will be skipped. So the for loop will continue, because you are using the continue in this case. So if this condition is true, you can see that this if statement is within the for loop body. This is the for loop body in between these two curly brackets. So if this statement is true, then the continue statement here would skip that instance, and the for loop will keep running until this condition is false before the for loop will terminate. And what will happen is just that all the numbers the user will enter will be added to each other, and the final sum will be printed. So that's why you have the plus equal sign here. So you run this, so enter n1, because here you have print function enter n. The data type here is for an integer, and I, initial value of I is 1, so that's why you have enter n1 here. So you are putting 5, so n1 is 5, enter n2 8, enter n3 9, enter n4 0, enter n5 4, enter n6 2. Now enter n7. Now if I put in negative 1 in this case, it will tell me to enter n8. What will happen is that at the end, this -1 will not be added, because the continue statement would skip this n7. So this -1 will not be added, because at that time this if statement is true, and the continue here would skip n7. So n7 will not be the number n7, which is -1, will not be added to whatever the total sum is. So before the for loop is terminated, I has to be equal to 10, which is n10, and we are still on n8. So n9 and n10 is 2. So you can see the total sum is 43. If you add all of this together, 5 plus 8 plus 9 plus 0 plus 4 plus 2 plus 9 plus 4 plus 2, you see that it will equal to 43. This n7 has been skipped because of the continue statement here. So that is what your continue does for you. If you want an instance in a loop to be skipped, then you use the continue. So let's look at the break statement. For the break, if you want an instance in a loop to terminate that loop, then you are using the break statement. So if you want an instance in a loop to terminate that loop, then you are using a break statement. So what we are doing is the same as what we did before, but here we are just using the break in terms of the continue. So what happens here is that, okay, once the number entered by the user is less than 0, if this is true, then the break statement here will terminate this loop. So this loop will be terminated once the number entered by the user is less than 0. Even if it's n1, even if it's at n1, the user put in a number that is less than 0, the loop will be terminated. So if you run this now, you see that enter n1. So if I put in -1 here, which makes this if condition to be true, the break statement here will terminate this loop. You will see that the loop will be terminated immediately. You can see sum equals to 0. The loop is terminated immediately because of the break statement. So if I run this again and I push in n1 as 7, you can see n2 will be requested, n3 will be requested, n6 will be requested. If I push in -9, the break statement will terminate this loop. You can see n6 was not printed because the break statement has terminated this loop. If you recall in the continue, if it's a continue statement that we have used here, what will happen is that n6 will be printed. So if I remove this break and I put in continue here, and I put in continue here, and I push in continue here, you see that if you put in -1, like we did the other time when we had break, you can see n2 will appear, because in this case I'm using continue. That, okay, at this instance still continue the loop, but if I'm using break, at this instance terminates the loop. So that's the difference between your continue and break statement. So that is how those two works. You can see, let's do that again. If I put in -1 now, you can see because it's break, to break, it will terminate that loop. So the next thing we'll be looking at is your pointers. Now when you want to use a pointer, you just want to use a pointer to know the address to which a particular variable is stored in your C language. With pointers, you can actually interact with the memory of your system. So that's why you are using a pointer. You want to know exactly the address of a particular variable that you have created in your C language. So what are the merits of your pointer? Number one, you can use your pointer to return multiple values from a function. You can use it to access any memory location in your computer's memory, and you can also dynamically allocate memories using the memory allocation, that is the malloc, and the core memory, that is the call-C functions in pointers. Then also pointers in C language, they are widely used in arrays, functions, and structures, and also it reduces the code and improves performance. So let's just look at the pointers. Here you would here I have a variable 5 with the identifier var, and the identifier is of integer data type. So what will happen is that this line will be printed, and here I'm using the pointer to actually print the location where this 5 is stored in the memory of this system. If you copy this code and put it on your own system, you will get another memory address. But here you see exactly what address is this variable 5 stored. So your pointer is %p to print the memory location or the memory address of variable 5. You can see now this is the memory address 0000024FE4C. That is the memory address of this variable 5 on this system. If you run this code on your system, you get another memory address because you are using a different system. So that's just pointers. Pointers just help you to know exactly the address in your system memory a particular variable has been stored. So that is what your pointer does for you. So that's for pointers. So your escape sequence are just any letter that is coming after your backward slash is an escape sequence. So the ones that we have been using repeatedly, that's your backward slash n, which is a new line escape sequence. So whenever you have a backward slash and any letter together, it becomes an escape sequence. So your backward slash A is alarm, backward slash B is backspace, backward slash F, that's your form field, new line, carried return, and you have your tab space, vertical tab for your backward slash V. So basically you use them probably when you are trying to address display devices, because when you are dealing with the display devices is when you need an escape sequence, and also when you are dealing with printers or you are sending maybe graphical controls, that's when you are using your escape sequence. You have other escape sequence here also when you have to have two backward slash, that's your back slash, where you have your backward slash apostrophe, that's your single quotes, double quotes, all of that. So these are escape sequence that you'd have in your C language. Then also you have functions, and there are two types of functions in your C language. You have your library functions and your user defined functions. So what function does for you, or the advantage of you using functions or creating functions in your C language, is that it avoids you having to write a particular program repeatedly, since you have created the function to address that kind of problem. Then also function can be called at any time and any number of time in a particular program. Then also your function makes you to have less line of code. It makes your code easier. Once you have a function you have already written, you can just call that function. You don't need to write those line of codes again. So it makes it your programming very smooth and very readable. Then also there's your function are highly reusable. So you can always reuse functions in your C language. So the rules for function is that you first of all declare your function. After you declare the function, you call the function, then you define the function. So number one, you declare the function, you call the function, then you define the function. That is the rule of function. So how do you use function in C? Number one, you can have functions without arguments, and you can have function without arguments that returns a particular value. Then you can have functions with arguments without returning values. Then you can have functions with arguments that returns value. So let's look at a particular function definition in C. So let's look at this function for the area of a triangle. So we said the sequence or the rule for your function, you declare the function, you call the function, then you define the function. So this is a global variable, and here is where I'm declaring my function, and the argument I'm putting into my function is my base, which is b, and my height, which is h. So these are the arguments this function area triangle is taking. So it's taking two arguments, b and h, which is base and height for my triangle. So that's my function declaration. So the next thing you want to do, you want to call the function. So here I'm putting my identifiers, which is my BH and area, and they are of the data type double. Then here also, the user will put in the base, the user will put in the height, and the scan function will take it in as B and H. Now this is my function call. Now I'm calling the function area try, which is this area try, and the two arguments are B and H, which is B and H. So this is the function call here. So what will be printed here is the area of the triangle, in this case, which will be r base times height. So this is the function call. The function definition now would be how the function will solve that problem. This is the function definition. So which is r base times height. You can see r base times height. That's the result. So this is a function with arguments that returns a value. You can see function with arguments and with return value. Function with arguments and with return value. So this is the argument B and H, and the value that will be returned is the area of the triangle. So if you run this, it will ask you to put in the base. So I'm saying 6, and I'm saying the height is 9. You can see the area of the triangle is 27.00 mm. So that is function definition, function declaration, function call, and the function definition. So that is what you have in terms of function. That is just the sequence for your function. Then the final thing we want to look at is your switch. So let's look at the syntax for your switch statements in this case. So you have your switch expression, you have the statements, then you have several cases that you want to check. So after each case, you put in your break until you are done with all the cases you want to check. Then you put in the default state. What is the default state of your statement? So you put in the default state. So let's look at the switch. So we look at the switch. In this case, this is switch statement. This is the switch. So this is your switch now. So in this case, we want to do a kind of calculator program, and we are just doing a basic mathematical calculator, which is doing addition, subtraction, multiplication, and division. So, and all of these are characters. So that is why the operators, these are my operators in this case, and the data type is character. That's why it is CHAR. It's a character. So the user will be requested to put in two numbers, which is the first number, the second number. The first number will be taken in as identifier N1. The second number will be taken in as identifier N2. And I'm declaring both of them as double here. So declaring them as double data type. So the first thing that the user will be requested to do is to put in the operator the user wants to use. And the operator has to be either positive, addition, subtraction, multiplication, or division. So in this case, after the user has put in that, the scan function here will take in that character as the operator. And in this case, the data type for operator using the scan function is your %C. That is why you have %C to take in the operator variable that the user must have entered. So after then, the two numbers will be requested by the user to put in. Then this is the switch expression. The switch expression is for the operator. So case 1 is addition, case 2 is subtraction, case 3 multiplication, case 4 is division. So what will happen in case 1 is this: whatever operator it is, So for the case 1 is to add the two numbers together. So case 1, addition. So you have the two numbers will be added and the result will be printed here. So that will break if the operator is not positive, is not addition. So to run into case 2. Case 2, to subtract number 1 from number 2, and that will only break if the operator is not negative, is not minus. It will run into the multiplication case. So it's multiply case, multiply number 1 by number 2, and the result will be printed as well. And if that operator is not multiplication sign, it will run into the division case. So it will divide number 1 by number 2, and the results will be printed. Now, if the operator is not any of this, is not addition, is not subtraction, is not multiplication, is not division, then that will be the default state. So the default now is that to print that the operator is not correct. So that is the default statement. So this is the switch. It will be switching from case to case with the break statement. So if you run this, so it will ask the user to enter any of these operators. So if I put in negative, to tell me to put in number 1, which is 6, number 2, which is 9. So this will be giving negative 3. You can see minus 3. That's number 1 minus number 2 equals minus 3. You can see this is case, the negative case that is being printed here. So if I put in what is not any of the operators, if I put in O, put in 9, put in 8, you can see now it's error, operator is not correct. You can see because this operator I put in is not like any of what should be taken in. So that is why the default statement is being executed. So that is for your switch, and that will be all for your control and loops. Thank you very much.